All right, this is lesson 12.4. It's our final matrix lesson for the year, okay? All right, so we're going to learn a method today called matrix algebra. Like I told you, I spent quite a bit of time this morning looking over and over and over through last semester's final. I do think there will be some problems on your final from this section. I think there will be 2 to 3. So again, it's an important section. And when we come to a problem that I think will be on your final, we're going to star it and mark it so then you can focus on that, okay? Okay, so when they ask you the order of a matrix, that just means the size. And when you find the size of a matrix, you put the columns times the rows. It's not really times, it's like by that X stands for. So if you look at this matrix A, you have 2 rows. Oops, I did that wrong. Sorry. It's not columns by rows. It's actually rows by columns. Sorry. So it's rows by columns. So if you look at this matrix A, you have 2 rows and you have 3 columns. So it's a 2 by 3. And if you multiply 2 times 3, you get a 6. And if you look inside that matrix, there are 6 things inside of that matrix. Okay? So question 1 is super easy, super wonderful. Find the size, find the order. So on question A, you have 1 number going down, you have 1 number going across. Question B, you have 3 numbers going down, you have 1 number going across. Question C is a 2 by 4. Super easy. Okay? Question 2 is also very easy. If one matrix is equal to another matrix, then the left corner is equal to the left corner. So you write down the 3, and then the next thing you see is an equal sign, and then you have a 3. Top right, x equals 5. Bottom left, y minus 1 equals 6. Bottom right, 4 equals 4. Great that 3 equals 3 and 4 equals 4, but that doesn't help me do my task, which is to find x and y. Well, I've already found x, it's 5. Then if I move my y over, I get y equals 7. Okay, now I want to say something right here. Oh, my pen is not working. I get y equals 7. There are your 2 answers, okay? Now I want to say something. You do not need to write this as the ordered pair 5, 7. If you do, I think they'll give you credit, but you're not supposed to. When you write it as an ordered pair is when it's given to you as an equation, as a system of equations. This was not given as a system of equations, it was given as matrices, so it would not make sense to write it as an ordered pair. Okay? Okay, question 3 is super simple. It's called scalar multiplication. So if this says take a 5 and distribute it across matrix A. So then that 1, 2, 3, 4 is matrix A. And then all you do, so easy guys, you just multiply all those numbers by 5. And you get 5, 10, 15, and 20. That's it. That's your answer. Question B is just as easy, but we're multiplying by negative 3. So 4 times negative 3 is negative 12. Negative 1 times negative 3 is a positive 3. 0 times negative 3 is a 0. 4 times negative 3 is a negative 12. Negative 3 times negative 3 is a positive 9. 8 times negative 3 is a negative 24. Done. Okay? All right. Now we're going to add or subtract matrices. Okay? Write a little note to yourself. Okay? And I want you to put add slash subtract. Okay? I want you to put must be same size. So you could never add a 2 by 3 to a 3 by 3. They have to be exactly the same. You guys, whenever I have a problem like this, the first thing I do is I always write down the order of each matrix. So matrix A is a 2 by 3, matrix B is a 2 by 3, and matrix C is a 2 by 2. C cannot be added or subtracted to A or B because it's a different size, okay? So take A and add B, okay? So I want you to write down matrix A, 2, 1, 0, underneath 3, negative 1, 5. And then go plus B, which is 4, negative 2, 3, 0, 1, 2, like that. So easy. All you do is just add the numbers or combine the numbers that are in the same position. So negative 2 and positive 4, you don't change any signs. You don't change the 4 to a negative or the 2 to a positive. You just combine those and you get a 2. Next position, 1 minus 2 is a negative 1. 0 and a 3 is a 3. 3 and a 0 is a 3. Negative 1 and 1 is a 0. 5 plus 2 is a 7. And I'm done. Very, very easy so far. Okay, yes, honey. I know what you're going to say. I don't know what you're going to say, but I'm guessing you're going to ask me, do you have to write that down? Okay, never mind. I think the answer would be no, just for that particular one. Okay, go ahead.
Okay, so if it was like on like C, how it's a 2 by 2, could you put zeros to make it a 3 by or 2 by 3?
No, because then you're changing the problem. You know what I mean?
But like in an equation, like if it was in an equation and you just added zeros to it, then it would still be the same.
If it was given in equations, then the correct matrix would be to add zeros. This is not an equation, and we don't change the matrix the way it's given. So you just leave it. Okay? Okay, so question B, you're trying to add a 2 by 2 to a 2 by 3, and you cannot do that. Okay? So this answer right here is not possible, and you're done. Okay? Question C. A and B are both the same size. Okay, now I want you to write this down with me. Everybody go negative 2, 1, 0, underneath 3, negative 1, 5. Then I want you to put a minus, and then I want you to put your matrix B. Okay? Now, I want you to listen carefully because I want you to get this right. See the middle? I don't ever want anything in the middle except the plus. That's all I ever want, because I want you to add these together. If there's a number there, like if this were like a negative 4, you would have to get rid of the 4 as well as the negative. Okay, so the first matrix is obviously not going to change because there's nothing in front of it. The second matrix is going to change. You're going to distribute that negative, and it's going to change all the signs. And then all you do is just combine the numbers that are in the same location. I don't say add and I don't say subtract because sometimes it's add and sometimes it's subtract. It depends on the signs. So just combine them. Don't change any signs. A negative 4 and a negative 2 is a negative 6. 1 and 2 is a 3. 0, negative 3 is a negative 3. 3 and 0 is a 3. Negative 1 and negative 1 is a negative 2. 5 and negative 2 is a 3. That's my answer. And I'm done. Okay? Who says, I like this kind of matrices? This stuff is easy. Okay, great. Let's keep going. No, I'm not saying anything negative. I said great. I said great. Okay, question 5. I want you to put stars around question 5. I am hoping that this will be on your final because it's very easy. Okay, I am going to change the problem. I want you to make it a 3b minus 2a. Okay, so I want you to put a 3. And then I want you to put matrix B, which is 4, negative 2, 3, 0, 1, 2. And then I want you to go minus 2 times matrix A, which is negative 2, 1, 0, 3, negative 1, 5. Okay, now I need you to listen carefully right here for a second. This is going to be an easy problem for most people. This is how it was given on the final. So it was not given as 3b minus 2a. They went right to what we just wrote. Doesn't matter. You can do it either way. So watch how simple. Okay, let's just be really clear. First of all, do you see that minus? These are separate matrices that are going to be added eventually. They are not multiplied together. The reason you can tell they're not multiplied is because you've got that negative in between. Who says I understand that? Okay. It's an easy problem, and that will cause you to fail on this. So just know they're added or subtracted. Distribute the 3, and you get 12, negative 6, 9, 0, 3, and 6. Distribute the negative 2, and you get 4, negative 2, 0, negative 6, 2, negative 10. And then you just add these together. So 12 plus 4 is 16. A negative 6 and a negative 2 is a negative 8. 9 and 0 is a 9. 0 and negative 6 is a negative 6. 3 plus 2 is 5. 6 minus 4 is a negative 10. And that's my answer. Oh, I said negative 4, and I wrote negative 4 and said something differently. Is that correct?
Yeah.
I did that a lot. Okay, there's your answer. That was easy. We could only hope that that would be on our final, right? It was on the final last semester. So let's keep our fingers crossed, okay? Okay, now we're going to multiply matrices. You've done this before, okay? Stop for just a second. Go ahead, sweetheart.
So, previously when we had a subtract, you changed the signs. Why didn't you change the signs on example 5?
I did, but I changed the sign. So if you look right here, honey, see this negative 2? Now it's a positive, positive, negative, positive, negative, negative, positive. I did change the signs, but I also multiplied it by 2. Does that make sense? So the negative changes the sign, and the 2 changes the number. Are you okay?
Mm-hmm.
Okay, great. Okay, multiplication. You've done this before. It's going to take a minute for you to remember. Okay, I want you to just stay calm. You're going to be fine. It's going to be rough at the beginning, and then you're going to be like, okay, I totally get this. Okay, okay, I want you to write this down. Middle number must match. When you're multiplying, up above that, put multiply. When you're multiplying, the middle number must match. Let me show you an example. If I'm trying to multiply a 2 by 3 by a 2 by 3, it is not possible because those middle numbers don't match. Okay, so that answer right there would be not possible. Okay, well, what if I was trying to do this? What if I was trying to multiply a 3 by 2 by a 2 by 2? You're going to want to write this down. This has come up before on a final, this little question. Haven't seen it for a while, but it could come up, okay? Could you multiply those together? Yes, you could. The result, or the answer, if you get rid of those 2's that match, the result is a 3 by 2. Okay, so I have seen a question on a final that says this, that reads this. If you multiply a 3 by 2 by a 2 by 2, the order of the resulting matrix is, and your answer would be 3 by 2. I would love it if that were on our final, okay, because that would be easy. Okay, question A is a 2 by 3, or matrix A is a 2 by 3. Matrix B is also a 2 by 3. C is a 2 by 2. And D is a 3 by 2. When I ever have a multiplication problem, you guys, I always check if it's possible at the beginning. If I don't check and it's not possible, I'm going to get confused. So I take 30 seconds and I check. So matrix C is a 2 by 2. Matrix A is a 2 by 3. Those match, and so it's going to work. Okay, now watch closely. The order matters. So do you see how A is C times A and B is A times C? You don't get the same answer. In regular math, 2 times 3 is the same as 3 times 2. You get 6 either way you do it, right? Not in matrices. It's different. So if that says C first, you must write C first, okay? So everybody write down C. 2, negative 2, negative 2, negative 2, negative 3, 3. Right next to it, write matrix A. So matrix A is negative 2, 1, 0, and then 3, negative 1, 5. Okay, now I want you to watch what I do when I do this problem. I know my answer is going to be a 2 by 3. So I'm going to set myself up right here to write my answer. And I do this. I know I'm going to have a row there and a row there. 2 rows. And I know I'm going to have 3 columns. Column, column, column. Those little marks are not necessary. I always do them so that I don't get confused how many rows and columns are in my answer. Okay? Okay, look at the first matrix. Underneath that matrix right there, I want you to write the word rows. Underneath the matrix underneath it, I want you to write down the word columns. Okay? So look what we do. It's a little confusing, so I want you to watch and everybody stay calm. Take this row, and you're going to multiply it by this column. Okay? And everybody just look forward and relax for just a second. This 2 is in position 1. This negative 2 is in position 2. So position 1, position 2. Then what happens is you take those numbers and you flip them like this. So this negative 2 is in position 1 and the positive 3 is in position 2. So look what happens. You just pair them up like that. So the 2 goes to the negative 2 and the negative 3 goes to, or the negative 2 goes to the positive 3. And you multiply them. So you go 2 times negative 2 is negative 4. Just jot it down on the side somewhere, okay? Let's just write down negative 4. And then negative 2 times 3 is negative 6. Now you just combine those and get a negative 10. Okay, let me do it again. You change columns. So now I'm going yellow to green. Okay, everybody watch. First number, second number, first number, second number. So it turns like this. It always turns like this. The bottom comes down. So the 2 goes to the 1. The negative 2 goes to the negative 1. So you go 2 times 1 is 2. A negative 2 times a negative 1 is a positive 2. And 2 plus 2 is 4. Now I change columns again. So the 2 goes to the 0, and the negative 2 goes to the 5. So 2 times 0 is a 0. 2 times negative 2 times 5 is a negative 10. 0 minus 10 is a negative 10. Now I'm out of columns. As soon as I'm out of columns, then I change rows. So I'm talking about this row right here, and then I go back to the first column. Okay, so look right here. The right one always comes down. So this is first position, second position, first position, second position. So the negative 3 goes to the negative 2, and the positive 3 goes to the positive 3. Okay, so you just go, negative 3 times negative 2 is a positive 6. 3 times 3 is a 9. 6 plus 9 is 15. Now I'm going red to green. Negative 3 times 1 is a negative 3. 3 times negative 1 is a negative 3. A negative 3 and a negative 3 is a negative 6. Now I'm going red to purple. Negative 3 times 0 is a 0. 3 times 5 is 15. And 0 plus 15 is 15. That's my answer. Who says got it? Let's see. Let me see how you're doing. Okay. Let's do another one. Okay. Everybody look forward for me. Okay. Here we go. Matrix A is a 2 by 3. Matrix C is a 2 by 2. My middle numbers do not match. This answer is not possible. I'm done. Okay, so is C times A the same as A times C? No. I got an answer and then I didn't get an answer. Okay, let's do question C. D is a 3 by 2. C is a 2 by 2. Is it going to work out? Yes, it is. Let's write down matrix D. The order matters. Right next to it, let's write down matrix C. Now look how I'm going to set up my answer, guys. Look, I know my answer is a 3 by 2. So I'm going to have 3 numbers going down and 2 numbers going across. Okay, here we go. Bless you. Green to yellow. The 1 goes to the 2. 1 times 2 is 2. The 3 goes to the negative 3. 3 times negative 3 is negative 9. 2 minus 9 is a negative 7. Now I'm going green to purple. The 3 drops down. So the 1 goes to the negative 2. 1 times negative 2 is a negative 2. 3 times 3 is 9. Combine those and I get a positive 7. I'm out of columns. So when you're out of columns, you change rows. So now I'm going pink to yellow. The guy on the right, on the pink, always drops down. So negative 1 times yellow, 2, that's a negative 2. 0 times negative 3 is a 0, so that just gives me a negative 2. Now I'm going pink to purple. Negative 1 times negative 2 is a 2. 0 times 3 is a 0. That gives me a 2. Okay, now I'm out of columns, so I'm going to change rows. So I'm going red to yellow. 2 times 2 is 4. A negative 4 times a negative 3 is a positive 12. 4 plus 12 is 16. Now red to purple. Negative 2 times 2 is negative 4. Negative 4 times 3 is negative 12. Combine, I get a negative 16, and I'm done. Who says I follow you? Raise your hand. Give me a big, huge raise up in the sky so I can see. Okay, most of us. All right, we're going to answer some true-false questions. If A and B are square matrices, a 2 by 2, a 3 by 3, a 4 by 4, even a 1 by 1, is it true that AB is the same thing as BA? Tell me. That is false. They are not the same. We just did that with question A and B. Okay? Okay, this came up on my final before as a complete surprise on final exam day. If you have A minus B squared, is that equal to A squared minus 2AB plus B squared? Okay? Well, in regular algebra it is. In matrices, it is not. Okay? So this answer is false. Question F, in real algebra it's true. In matrices, it's false. Now, I want to tell you what I did. Listen what I did. And some of my students did this because I talked to them after. I'm like, how did you decide what to put? Look what I did. I made up something for matrix A. I made it as easy as I could. Okay? And then I made something up for matrix B. And then I plugged them in. If I subtract them, I would get this. 0 minus 3 is a negative 3. 1 minus 0 is a 1. Negative 2 minus a negative 1. That is a negative 2 plus 1, which is a negative 1. 3, oh, I'm supposed to be subtracting. 3 minus 4, negative 1. So that's that solution right there. And then what I did is I squared it. So I multiplied it by itself. And I saw what I got. And then I did this. I took that same A, multiplied it by itself, took A and B, times them together, distributed negative 2, took B, multiplied by itself, added the 3 things together, and I saw if I got the same thing. Okay, I literally went through that whole thing, and the answer is false. Okay, so the easiest thing for you to do is just remember that if we're talking about matrices, the answer is false. Okay, it came up on a final. Do I think it's going to be on your final? No. But if it does come up on your final and you go through your workbook, then hopefully you'll just remember that it doesn't work out with matrices. Okay? All right. Now we're going to find the inverse of a matrix. Okay? If matrices are inverses, then here's the truth. Look at this. You take the original, You multiply it by its inverse, and you get the identity. Then you go the other way. You take the inverse, and you multiply it by the original, and you also get the identity, okay? What's the identity? We talked about that last time. It's that for a 3 by 3, and it's that for a 2 by 2, okay? So show that they're inverses. You guys, it says show. So if it says show, then I know it's going to work out. I know they're really inverses, okay? So I want everybody to draw a line right there. Just cut that thing in half, okay? So you're going to write down matrix A. Right next to it, you're going to put matrix B. On the other side, you're going to do the same thing, but in the other order. So it's going to be like this. B and then A. Now I'm going to show you a trick. It says show. So I know they're inverses. If it said determine if, that's a whole different ballgame. But I know these are inverses. So if these are inverses, when I multiply the inverses together, or the original and the inverse, regardless of the order, I'm going to get the identity. So guess what I could do? I could fake it. Because I know it's going to work because it says show. So I could just say, yay, I multiplied those together, and I got the identity. Does anybody know that I didn't multiply those together? Nope. There's no work required. Okay? Now, the only reason I can do that is because it says show. If it says determine if, anyway, determine if, then you actually have to do it, okay? Just freeze for 2 seconds, and let me show you something. Look right here. Just relax. Yellow, pink times yellow. Watch. 1 times -3 is a -3. 1 times 4 is 4. 0 times -2 is a 0. And -3 plus 4 is a 1. I know. It's crazy. Then pink to green. 1 times 1 is 1. 1 times -1 is a -1. 0 times 1 is 0. 1 minus 1 is a 0. I could continue with both matrices. We don't have to because it says show. Okay? All right. Basically, what you need to know right here is not every matrix has an inverse. Sometimes it won't work out. If it doesn't have an inverse, it's called singular. Okay? If it doesn't have an inverse, it's called singular. Okay, here we go with 8. Set up an augmented matrix for finding the inverse. I do think you're going to have a problem on your final that says find the inverse. There was one last semester, okay? Here's how you set it up. It's very simple. You take matrix A, which is over here. Okay, so it's going to be 3, -3, 1. Then you're going to do a solid line. Don't do anything to the right of that solid line. Underneath, 1, 2, -4. Underneath, -1, -3, 1. So you put matrix A on the left, and what goes on the right is the identity. So it goes like this. That is your setup. That's the whole thing that you have to do, because all they're asking me to do is set it up. Some of you need to be better at reading the directions, because, for example, on test 3, there was a problem, and it said, set up the equation as if you're ready to solve. It was like, how long for money to triple or something like that. If it doesn't say solve, you just set it up, just like that. That's a setup. We didn't do anything yet. We just set it up, okay? Someone's hand went up. Shh.
I was just wondering, how do you know that that one's A?
It's always A. The one that has the X and Y and Z is defined as A. We talked about it before. That's your A, and that's your B. Okay? It's just the definition of it. All right, we're going to go slowly. Okay? Find the inverse. Okay? Here's what you do. You put matrix A on the left. You put the identity on the right. Then you manipulate it so you have the identity on the left and your inverse ends up on the right. Okay? So here we go. Take your A and put it on the left. On the right goes your identity. Now, I have to turn the left-hand side into the identity, okay? The first step, remember the order I told you last time on a 2x2 is this? 1, 2, 3, 4, like that, okay? So the first thing I need to do is put a 1 right there. And everybody freeze. To make that a 1, I have to divide by 2, but dividing by 2 creates a what? Creates a fraction. Don't do it. Don't do it. Do not make a fraction. So I'm skipping step 1, okay? And I'm going to go to step 2, okay? Thank heavens it's easy because I can turn the 2 into a -4 paired up with a +4 and I've got my 0. So I'm going to go -2 times row 1 added to row 2 becomes my new row 2. So row 1 doesn't change. Multiply the top by a -2 and you get -4, 8, -2, and 0. You do all the way across. Then you write row 2 underneath it and you add those together. Remember, I don't want you changing signs right here. Set it up so you don't have to change any signs. And you get 0, 1, -2, and 1. So I got a bonus, you guys, because I was going to change the 4 to a 0. And when I did that, I also got a 1 right there. So I got a 2 for 1. That's awesome. Okay, now I need to turn that guy into a 0. Use the 1. So I'm going to go 4 times row 2 plus row 1 becomes my new row 1. So row 2 doesn't change. Multiply a 4 across the bottom and you get 0, 4, -8, and 4. Write row 1 underneath it, add those together, and you get 2, 0, -7, and 4. Now I have to make the 2 a 1, which is going to create a fraction. Who cares? Because I'm going to be done at that point. I don't care if the fractions come at the end. I don't have to deal with the fractions. So I'm just going to go row 1 divided by 2 becomes my new row 1. So row 2 doesn't change. Take row 1 and divide by 2. And I get 1, 0, -7 over 2. 4 divided by 2 is a 2. And I'm done. So the way you write your answer is, my inverse is -7 over 2, 2, -2, comma 1. If you don't write that down, just like that, I am sure they're going to take off a chunk of points. Okay? Yes, honey? It would, but the problem is, then you're dealing with horrible fractions the whole way through your problem, which is just going to cause so many problems. So yes, it does not matter. I would not do it. Okay? All right. Here we go with the next one. Grab your pencil and put stars all around it. I spent the morning looking at last semester's final, and this was on it. Okay, here we go. Put matrix A on the left. Solid line, identity on the right. This is really no different than what we've been doing. The right-hand side is just bigger. That's the only difference. It's not any more difficult. Okay? The first thing we need, you guys, is a 1 right there. Done. The second thing I need is a 0 right there. Okay? Now I'm going to say something right now, and I want you to freeze. If what I say does not make sense to you, then don't worry about it. If you can follow me, it's going to make it easier. Okay, everybody look right here, and I don't want you to write for a second. Okay? We could go row 1 minus row 2 becomes my new row 2. We could also do row 2 minus row 1 becomes my new row 2. Please don't write if you're writing. I want you to look up. 1 is better. 1 is better than the other. If you choose wrong, it's okay. It's just going to be more work. But if you can look ahead and figure out which one's better, it's less work for you. Can anybody see which one's better? Which one? The second one. Why is the second one better than the first one? Well, I'd get a 0 either way because it turns the center into a 1. I would have 2 minus 1, which gives me a 1. So if I choose correctly, I get a 2 for 1. I get 2 numbers turning into what they're supposed to be in one step. And so that's a beautiful thing. Now everybody go row 2 minus row 1 becomes my new row 2. If you choose wrong, big deal. You just have to go through and change the signs. It's not a big deal, but it saves you work. Okay? Okay, so guys, here we go. Row 1 doesn't change. Row 3 doesn't change. Row 2 minus row 1. 1 minus 1, 0. 2 minus 1, 1. 1 minus 0, 1. 0 minus 1, negative 1. 1 minus 0, 1. 0 minus 0, 0. Watch me closely. If I make a mistake, stop me, okay? Because I can make them just as easily as you. The third number I need to get to be right is that one. Use the 1. So go negative 2 times row 1 plus row 3 becomes my new row 3. So row 1 doesn't change. Row 2 doesn't change. Take a negative 2 and distribute it across the top. Negative 2, negative 2, 0, negative 2, 0, 0. Write row 3 right underneath it. Add those together and you get 0, 1, 2, negative 2, 0, and 1. Raise your hand if you need me to slow down a little bit. Okay, no problem. Okay, the next thing I need is a 1 here. Well, I've already got it. So the next step is to get a 0 right there. And everybody freeze and just look at it. I can do row 2 minus row 3 or row 3 minus row 2. It doesn't matter. They're both right. 1 is better. Which one's better? Row 3 minus row 2. Because row 3 minus row 2 gives you a 1 there, which is my next step. So I'm going to go row 3 minus row 2 becomes my new row 3. Row 1 doesn't change. Row 2 doesn't change. Row 3 minus row 2. That's the only scenario I'll ever put a negative in the center, just so you know. I always put a plus unless I'm doing one row directly subtracting another row. So 0 minus 0, 0. 1 minus 1, 0. 2 minus 1, 1. Negative 2 minus a negative 1. That's a negative 2 plus 1, which is a negative 1. 0 minus 1, negative 1. 1 minus 0, 1. The next thing I need is a 0 right there. Remember, for that position, I cannot use row 1 because this one and this one will mess up this 0 and this 1. Which one is correct? Row 2 minus row 3 or row 3 minus row 2? Which one's correct? 2 minus 3. Row 2 minus row 3 becomes my new row 2. If I do the other order, it turns my center 1 into a negative 1, and I don't want it. If it happened, big deal, I could change the signs, but let's do it right. 1, 1, 0, solid line 1, 0, 0. That's row 1. Row 3 does not change. Now I'm going to subtract row 2 and row 3. So 0 minus 0, 0. 1 minus 0, 1. 1 minus 1, 0. Negative 1 minus a negative 1. That's a negative 1 plus 1, which is 0. 1 minus a negative 1. That's 1 plus 1, which is a 2. 0 minus 1, negative 1. I'm almost done. Keep in mind as we go through this, this was on the final last semester. Same thing. Okay? Okay, I need to get a 0 right there. I'm going to use row 1 and row 2. Every person talk to me so I can see if you understand. What is better, row 1 minus row 2 or row 2 minus row 1? Tell me. 1 minus 2. Yep. So I'm going to go row 1 minus row 2 becomes my new row 1. Okay? So row 2 doesn't change. Row 3 doesn't change. Row 1 minus row 2. 1 minus 0, 1. 1 minus 1, 0. 0 minus 0, 0. 1 minus 0, 1. 0 minus 2, negative 2. 0 minus a negative 1, that's 0 plus 1, which is 1. And I'm done. Please don't go through all that work and not write it down correctly. Guys, they are so picky. And this is how they expect you to write it. 1, negative 2, 1. 0, 2, negative 1. Negative 1, negative 1, 1. That is my inverse. And I'm done. Who says gotcha? Let me see. Okay. We have more. But the 2 problems that were on your final, we've already done them. One of them is that one, and the other one is back over here, this one. Okay, so the rest of it, I'm still going to teach it to you. I'm going to put it on the quiz, probably not going to be on the final, which is good news. Okay, okay, here we go. Matrix algebra. We only have 2 problems left. Matrix algebra is the only method really that I'm teaching you today, the method for solving. It involves finding an inverse, okay? Here's the formula for matrix algebra, okay? Jada, when I told you that the left side was matrix A, you just still kind of seemed confused to me. It's just a definition. When you get a system of equations, the side that contains the x's and y's and z's is defined as matrix A. So if you ever had a problem that said, you don't have to write this down, here's a system, tell me what matrix A is, your answer would be 1, 1, 0, 1, 2, 1, 2, 3, 2, and you'd be done. It's the definition. Do you understand? Okay. Matrix B is over here. Okay? So here is the formula for matrix algebra. Okay? Here's what you do. You put matrix A on the left. You put the identity on the right, just like we have been doing. You change the A so that it's the identity, and on the right is the inverse. That's exactly what we just did. But then to solve the system, you take the inverse, and does anybody remember what you do? You put it in your calculator for the last couple of years, but you've never really had to do it. Does anybody remember the buttons that you push on your calculator? You take the inverse, and what do? Times it by B. It's exactly what you do. And that's your answer. That's the formula. Okay? See that formula I just wrote down? You have to memorize it, because you have to know the difference between Gaussian, row echelon, Gauss-Jordan, Cramer's rule, and matrix algebra. You have to keep them all straight. Okay? All right, here we go. Nice and slowly. Okay? Matrix A, 1, 1, 0. Then do a solid line. Underneath, 1, 2, 1. Underneath, 2, 3, 2. Yes. They'll tell you what method to use, yes. And if you use a different method, you get nothing. They will tell you what method, yes. Yes. Okay, here we go. 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay, nice and slowly. The first thing I need is a 1 right there. Thank heavens we have it, right? The next thing I need is a 0 here. I can do row 1 minus row 2 or row 2 minus row 1. There are so many ways to do this. This is why you have to give me a formula. So if you mess up, I can give you as many points as I can find. Which one's better, 1 minus 2 or 2 minus 1? 2 minus 1. So everybody write down, row 2 minus row 1 becomes my new row 2. So row 1 doesn't change. Row 3 doesn't change. Row 2 minus row 1. 1 minus 1, 0. 2 minus 1, 1. 1 minus 0, 1. 0 minus 1, negative 1. 1 minus 0, 1. 0 minus 0, 0. The next thing I need is a 0 right there. Use the 1. So go negative 2 times row 1. Added to row 3 becomes my new row 3. So row 1 doesn't change. Row 2 doesn't change. Distribute a negative across the top. Negative 2, negative 2, 0, negative 2, 0, 0. Write row 2 underneath it. Add those together and you get 0, 1, 2, negative 2, 0, and 1. Yes. Said it wrong, did it right. Sorry. I do that all the time. I don't know why. It's my brain. The next thing I need is a 0 here. I can do row 2 minus row 3, or I can do row 3 minus row 2. One is better. Which one's better? 3 minus 2. Yes. Row 3 minus row 2 becomes my new row 3. Row 1 doesn't change. Row 2 doesn't change. Row 3 minus row 2. 0 minus 0, 0. 1 minus 1, 0. 2 minus 1, 1. Negative 2 minus a negative 1. That's a negative 2 plus 1, which is a negative 1. 0 minus 1, negative 1. 1 minus 0, 1. The next thing I need is a 0 there. I cannot use row 1. I can do row 3 minus row 2, or row 2 minus row 3. Row 2 minus row 3 is better because it doesn't mess up my center 1. It keeps it a 1, okay? Row 1 doesn't change. Row 3 doesn't change. Go row 2 minus row 3. 0 minus 0, 0. 1 minus 0, 1. 1 minus 1, 0. Negative 1 minus a negative 1. That's negative 1 plus 1, which is a 0. 1 minus a negative 1. That's 1 plus 1, which is a 2. 0 minus 1, negative 1. The last thing I need is a 0 here. I could do row 1 minus row 2 or row 2 minus row 1. Row 1 minus row 2 is better. It becomes my new row 1. Row 2 doesn't change. Row 3 doesn't change. Row 1 minus row 2. 1 minus 0, 1. 1 minus 1, 0. 0 minus 0, 0. 1 minus 0, 1. 0 minus 2, negative 2. 0 minus a negative 1, that's 0 plus 1, which is a 1. Now you say this, I know my inverse is the right-hand side. To solve this system, now I have to take that inverse and I have to multiply it by b. So I'm going to write down my inverse that I just found. And I'm going to multiply it by matrix B. What is matrix B? Do you remember? That's the right-hand side, right? Which is 20, 30, and 55. You guys, make the inverse is a 3 by 3. I'm multiplying it by a 3 by 1. The 3's match. My result is 3 numbers down, 1 number across. Okay, here we go. This row right here, you use the rows, or that matrix, you use the rows, and this matrix, you use the columns. The numbers, the one on the right, the yellow one on the right, comes down to line those up. So 1 times 20 is 20. A negative 2 times 30 is a negative 60. 1 times 55 is 55. Combine those, and I get 15. Now I'm going to change rows on the left. The negative 1 that's highlighted pink comes down to the 55. So 0 times 20 is 0. 2 times 30 is 60. Negative 1 times 55 is a negative 55. Combine, and you get a 5. Now I'm going to change rows at the bottom. Negative 1 times 20 is negative 20. Negative 1 times 30 is negative 30. 1 times 55 is a 55. Combine, and I get a 5. That is not how you write your answer. It was given as a system. Did I do it wrong? Are we okay? It's so funny. Kath, I'm going to tell you something. That makes me laugh because every year I do this, I mess up on those numbers. And it's like adding and subtracting. But I always, so as soon as you said that, I was like, Am I wrong? Because I'm always wrong. I know. So I always do the same thing that you just did. So my answer is 15, 5, and 5, and I'm done. Do I think that type of problem will be on your final? No.
Yes.
I said no. I'm just kidding.
I know.
You were celebrating. I said no, and you said yay.
Yeah.
Yeah, but it was confusing. Okay. I do not think that will be on your final. Will it be on your quiz? Yes, it will. Yes, it will. I'm not blowing it off. If I blow it off and it shows up on your final, I failed you, and I don't want to fail you. Okay? Look at question 12. Here's my A. Here's my inverse. Don't say anything for a second. Here's my inverse. Use the inverse to solve. Look what my students did. They put this big A, and then they put the identity, and then 10 minutes later, they had the inverse. Do you need to do that? They gave you the inverse. So all you have to do is this. Write your inverse down and multiply it by, tell me.
4, -5, 2.
Yeah, by matrix B, which is the right-hand side, 4, -5, 2. This is a 3 by 3. This is a 3 by 1. Those match. Your answer is going to be 3 down and 1 across. This row times this column. The yellow number on the right always swings down to line those up. So -2 times 4 is a -8. -1 times -5 is a +5. 1 times 2 is a 2. Combine and I get a -1. Change rows. Didn't mean to scribble that. Change rows. So 5 times 4 is 20. 3 times -5 is -15. And -1 times a -5 is a +5. Combine and I get 10. Now I'm going to change rows. Am I okay? It is. He's funny. I think you messed up. You're right. That's supposed to be a -2. Is that correct? Okay. So then this 10 is really going to be a 3. Am I good? Who says I agree with you? Okay. Can you imagine doing this? My shoes, and you have 30 people watching your every move, and of course you're going to make mistakes. This is 1,000 numbers, right? But it's okay. I'm confident, so it's fine. 1 times -4 is -4. -1 times -5 is a +5. 0 times 2 is a 0. -4 and a +5 is a 1. If you do the whole problem, like say the problem before, and you do the whole problem, and then you're done, and you highlight that answer, they're going to take points off. Because they need you, they insist that you write it as a triple, which is that. By the way, that problem right there, please listen, that problem right there, this problem right there, not that one, well, yeah, that one, but can you check those? Easily, right? Plug them back in, make sure they check out, and you're good.